So, welcome everyone to our new session, which is on Vsepr Theory. Vsepr Theory. Valence share electron pair repulsion theory. We will discuss today valence share electron pair repulsion theory. So the basic what idea is to start with the postulates of this theory. Postulate 1, I am referring the NCRT. Please open the NCRT book. The geometry of a molecule depends upon the total number of valence shell electron pairs, bonded or non-bonded, around the central atom. Means the geometry, I am writing in short, geometry depends on the central atom. On the central atom around which are shared atoms. Means like this, in case of water, H2O, O is the central atom, so H. So overall, on the overall structure, the geometry is depending on the overall structure contributed by the central atom as well as the shared atoms, plus bonded electrons as well as the lone pair electrons. Bond pair electrons plus lone pair electrons gives us the geometry. This is the meaning of the first postulate, that if you are talking about the geometry of the molecule, you have to consider the whole system in which the central atom is bonded or not bonded. Means bond pair plus lone pair gives us the geometry. This is the shortcut we are getting. Bond pair plus lone pair gives us the geometry. So I can write G is equals to bond pair plus lone pair. We got a I can say curved equation for the first postulate of Vsepr theory. First postulate is clear to everyone. Okay. Now I am writing the second postulate. We'll do this session slowly, because this is quite important to understand the postulate as well as what is the concept around the topic. Second is pairs of electron in valence shell repel one another since the electron cloud are negatively charged. Means what they are saying, pairs of electrons of the valence shell वो repel करेंगे एक दूसरे को. They are repelling each other because the electron cloud वो negatively charged है. So यहाँ पे अपने को दिख रहा है second point पे valence electron pairs are repelling each other since the electron cloud is negatively charged. And how they are repelling each other, I will tell you. Suppose this is the molecule NH3. Wait, I will draw here NH3. So I will show you the repulsion. NH3 lone pair here, 3 bond pair. So this is repulsion, lone pair, bond pair repulsion, bond pair repulsion, so that they could be maximum stable and will have less energy. Means it is type of repulsion here. Lone pair bond pair repulsion, bond pair repulsion, bond pair repulsion, so that they have minimum energy and maximum stability. This is the second postulate. And also the third postulate here, they tend to occupy positions in space to minimize the repulsion. Means here they are attaining a certain position so that their energy is less and stability is more. The third point also is covered here. Arrangement in space is also cleared. Okay, now let's move to the fourth point. The valence shell is taken as a sphere with electron pair localizing on spherical surface at maximum distance to one another. Same they are repeating, means same they are like repeating. Such say H2O, OH. So here there is repulsion between the electrons. Bond pair, lone pair, bond pair, lone pair. So that in such a way they are arranging themselves so that they are minimum energy and maximum stability they are getting. That way they are arranging each other. That's all the fourth point is telling us. Same second, third and fourth point are interrelating to one another. Got it. Now, one important. You must be thinking that I am saying lone pair repulsion, lone pair bond pair repulsion, and bond pair repulsion. The order is that lone pair repulsion is greater than lone pair bond pair repulsion is greater than bond pair repulsion. Means the amount of repulsion done by lone pair will be maximum. After that, lone pair bond pair, and then bond pair minimum. Okay, that is clear. The point is also cleared. Fifth point is also clear. Multiple bond is treated as if a single electron pair. Multiple bond is considered as single electron pair. Multiple bond is considered as single electron pair. Means in this pi bond is not taken into consideration. The pi bond, which is the double bond, sigma is the first single bond, then there is a pi bond. Pi bond is formed by side overlapping, by parallel overlapping. So we can say that pi bond का इधर कुछ लेना देना नहीं है, because pi bond is directly treated as single bond ना. It is directly treated as a single bond. Therefore, this 6th point is also cleared. Now, the last postulate in your NCERT textbook mentions what? That we will see, and then we will solve a good number of tricks I will give you. Also, we will solve some questions so that this Vsepr theory is crystal clear to everyone. So, last postulate, that is 7. So, if two or more resonance structures are present, Vsepr model is applicable for all. VSEPR model is applicable to all to all resonance structures or all canonical structures. Resonating structures, to all resonating structures, one single VSEPR model is sufficient to all resonating structures. That is the 7th point in the NCRT, and this way we have completed the postulates. I am revising the postulates. The geometry of a molecule depends upon the total number of valence shell electron pairs around the central atom. Pair of electrons in the valence shell repel one another since the electron clouds are negatively charged. Third, these pairs of electrons tend to occupy such position in space that they have minimum repulsion and maximum stability. Fourth, valence shell is taken as a sphere with electron pairs localizing on spherical surface at maximum distance to each other, far away from each other, so that their stability could be maximum. Multiple bond is treated as single bond, and 2 or 3 electron pairs of the multiple bond are treated as single super bond. Okay, where 2 or more resonating structures are present, one VSEPR model suffices. Lone pair interaction is greater than lone pair bond pair interaction is greater than bond pair interaction. The presence of lone pair will result in distortion. Will result in distorted arrangement. That also we will see one by one. Okay, now I will tell you how to calculate steric number. That is our main aim. How to calculate steric number, that you will study in hybridization also. I will upload a video on hybridization. That is also quite an interesting concept. Let's study how to calculate steric number. Steric number is Z. Two methods of steric number I have with simple sigma bond plus lone pair plus unpair electrons on lone pair and unpair electrons on the central atom. This is the first formula. Central atom I will write, yes, lone pair on the central atom. Number of sigma bond plus lone pair of the central atom plus unpair electrons on the central atom. If odd electron species are present, we can calculate by the sum of these three the steric number, which is Z. I will give you 3 questions to write fast. CH4, H2O, NH3. Pause the video and comment the steric number. Comment the steric number in A, B, C. That's the challenge for you. Comment the steric number in A, B, C. Okay, now I am solving. I will give you the structure for this. Okay, let me give the structure. Okay, let me give you the structure for first method. Yes, the structure is given to you. Now, let's see who is going to comment the answer first. That is ABC, steric number for ABC. Okay, now I will tell you. So first formula, sigma bond कितने इसमें CH4 में 1 2 3 4 सिंगल बॉन्ड्स आर सिग्मा बॉन्ड 4 सिग्मा बॉन्ड्स. लोन पेयर है क्या सेंट्रल एटम पे? नहीं है. अनपेयर है क्या? नहीं है. 4 + 0 + 0 Z is equals to 4. यहाँ पे ही तुम्हें बता रहा हूँ. If Z is equals to 4, hybridization is sp3. Hybridization is sp3. I will give you the whole chart. Don't worry, I will give you the whole chart. Next question पे आ जा. H2O. H2O. सिंगल बॉन्ड कितने हैं बॉस? दो है. दो सिंगल बॉन्ड. लोन पेयर O पे कितने? Two lone pair on the O atom. Unpair, no unpair electrons. 2 plus 2 plus 0, 4 again. Z is equals to 4 again. What? sp3, right. NH3. 3 sigma bonds plus 1 lone pair and no unpair. 3 plus 1 plus 0. Z is equals to 4 sp3. So तीनों का Z same है, but the arrangement you can see is different because of this theory. Vsepr theory is making, the lone pair is making distortions in the structure. This is bent, H2O is bent, and NH3 is like a pyramid, but CH4 is what? Tetrahedral. It's right. That also I will be providing you in this video. Don't worry. Those who have already done this chapter, revise. Yes. Okay, done. Now second method I will give. Second method. First method is clear of calculating Z. That was our aim. Second method. Half bracket valence electrons on the central atom plus negative charge minus positive charge plus number of monovalent atoms. Monovalent atoms like fluorine, chlorine, hydrogen, iodine, bromine. That case is monovalent, you all know. Now let me give you some questions. To check your knowledge. And here I need not to draw the structures. Okay. First is PCl5. One I will write. Second I will give XeF4. 3 SF6. 3 is SF6. So 1, 2, 3. Comment the Z for each of the following. Let's see who is commenting first. Let's see. Okay. Challenge. Take as a challenge. Those who are revising, take as a challenge, and those who are studying it for the first time, use the formula. Simple way. Okay. Z is equals to now half valence electrons on the central atom. Phosphorus के कितने valence electrons होते हैं sir? 5 होते हैं. Okay. Half bracket 5. Any positive negative charge दिख रहा है क्या? No. Monovalent है क्या यहाँ पे? Yes, chlorine is monovalent sir. कितने है? 5 है. 10/2 5. Z is equals to 5. पहले का आंसर है. बता के रख रहा हूँ. 5 आया तो क्या कर देना? sp3d. Hybridization भी दे दिया. sp3d. Don't worry, I will teach you that. Okay. Z half. Xenon का क्या है बॉस? Xenon का वैलेंस इलेक्ट्रॉन्स में 8 रहता है. नोबल गैस है. 8 प्लस चार्ज है क्या कोई? नो चार्ज. मोनोवैलेंट. फ्लोरीन इज मोनोवैलेंट. प्लस 4/2 कितना आ रहा है? 12/2 6. Z is 6. sp3d2 आ रहा है सर. sp3d2 आ रहा है. Okay. Everyone is getting this. sp3d2 is coming simple. For SF6, let's check. 6 plus no charge monovalent 6 divided by 2. Z is equals to 6. sp3d2 is coming. Simple it's coming. So by two methods we have learned to calculate the value of z, that is steric number. Now let's see now what each and every cases in detail, each and every cases we are studying in detail. Okay, first I will write if number of bond pairs, number of lone pair, and formula also I will make a table, and molecular shape I can write simple, and geometry. Now you will see the difference between geometry and shape. From this we'll see a difference in geometry and shape. So number of bond pair, if I have taken 2, lone pair 0, AB 2, shape क्या होगा सर? 2 है, no lone pair. Now remember, in shape we only consider bond pair and no lone pair, but in geometry we are considering lone pair plus bond pair. In shape, no lone pair. So here as it no lone pair, दो बॉन्ड पेयर है, z is equals to 2, z is equals to 2. शेप क्या होने वाला है? शेप क्या होने वाला है? लीनियर, ज्योमेट्री also linear. So we can conclude that if z is equals to 2, the geometry is linear, and if there is no lone pair, the shape is also linear. If there are no lone pair, shape is equal to geometry. That we can conclude. 2 and okay, plus, let me take plus easy. I will take 3 0. If there are no lone pair, then shape is equal to geometry. मार के आने का, shape is equal to geometry. So what will be there? AB3, shape trigonal planar, and geometry also trigonal planar. 3 आ रहा था तो z is equals to 3. sp2 trigonal planar, shape and geometry also trigonal planar because lone pair 0 है. 4 0, AB4 I will write, AB4. What will come? Tetrahedral. And here also tetrahedral. Shape is equal to geometry if there are no lone pairs. If 5 bond pair, that is sp3d 0, AB 5. General formula AB5. A is the central atom and B are side atoms. What way it will come? TBP, trigonal bipyramidal. TBP, short form I am using, trigonal bipyramidal. Okay. 6 0, AB6. Yes, sp3d2, no lone pair, shape is equals to geometry. Octahedral. Here also octahedral. Understood? 7 0, AB7. What is for 7? Pentagonal bipyramidal. PBP, pentagonal bipyramidal. PBP, shape and geometry are same if there are no lone pairs. Shape is equal to geometry. This was general. Generally I can say if no lone pairs, then z is equals to 2 हुआ तो shape linear, geometry भी linear. Z is equals to 3, no lone pair, trigonal planar. 4 is equals to tetrahedral. 5 is equals to no lone pair, TBP, trigonal bipyramidal and trigonal bipyramidal. 6 हुआ तो ऑक्टाहेड्रल ऑक्टाहेड्रल 7, नो लोन पेयर आया तो पेंटागोनल बाइपिरामिडल एंड geometry also pentagonal bipyramidal. Now let's see the variations. If lone pair is coming, the shape will vary because shape का lone pair से कोई लेना देना नहीं है, shape का lone pair से कोई लेना देना नहीं है. Okay, if it is 2-1, 2-1, 2 bond pair, 1 lone pair, 2 bond pair, 1 lone pair, what it will be? What it will be? Shape. What the shape will be? And what is the geometry? Shape will be bent shape, but the geometry will be as it is. Z is equals to bond pair plus lone pair. तो ज्योमेट्री क्या होगी? Z is equals to 3 की ज्योमेट्री होगी. क्या होगी ज्योमेट्री? Trigonal planar will be the geometry. Trigonal planar will be the geometry. Simple trigonal planar. Next क्या है? 3-2. पहले 3-1. Okay, 3-1. 3-1. क्या हो रहा है? 3-1. शेप में चेंज आ रहा है, शेप में चेंज आ रहा है. यस, ट्राइगोनल पिरामिडल, ट्राइगोनल पिरामिडल. बट ज्योमेट्री 3+1 4. Z is equals to 4 के लिए क्या होती है? ऑक्टाहेड्रल. ज्योमेट्री विल रिमेन द सेम, ओनली द शेप इज चेंजिंग, ओनली द शेप इज चेंजिंग. Now we will discuss 3-1 is finished. 2-2. It will come bent as I've shown in the first water H2O. 2 lone pair and 2 lone pair. Bond pairs are 2. Lone pair को छुपा दो. दो ऐसे V type दिख रहा है, bent shape दिख रहा है तुम्हें, bent shape. 2 + 2 4. This will be same octahedral, sir. Octahedral. Geometry is same but the shape is varying. That you can see. Next क्या है? 4-1. Now see 4-1. Shape is coming seesaw. I will show this all by drawing to you. I will give you questions and draw also. Seesaw 4 + 5. This will be same TVP. Trigonal bipyramidal. Geometry is same. Now 3-2. T-shaped, but geometry again same. 3 + 2 Z steric number 5. TBP. Simply it is coming same geometry. And if there is 5-1, square pyramidal, but geometry again octahedral, the same. 5 + 1 6, Z6 octahedral. If 4-2, square planar, but geometry again octahedral. We are seeing that the shape is varying but the geometry is same, because remember that shape does not depends on lone pair. Shape does not depends on lone pair. 2 tables you have to note down clearly. Clearly, or I will draw some structures for better understanding. Let's take SI4. It's a normal. Z we will calculate by formula half. Valence पे कितने 4. No charge 0. Fluorine का कितना है? Calculate करो जल्दी. Z is equals to 4. If Z is equals to 4, sp3 geometry and tetrahedral I am writing. Tetrahedral. So here geometry is equals to shape I can say. लोन पेयर नहीं आ रहा है तो ज्योमेट्री इज इक्वल्स टू शेप. अभी स्ट्रक्चर देखो, स्ट्रक्चर आई एम ड्राइंग बिग. यस, this angle is generally 109.5. so this was first example SIF4. for Z calculate करो, hybridization दिखाओ sp3 और तुम्हें मालूम है Z is equals to 4 के लिए क्या रहता है, टेट्राहेड्रल रहता है. स्ट्रक्चर बनाओ, एंगल मालूम है तो लिखो, नहीं तो यू कैन लीव इट एज इट इज. नाउ नेक्स्ट वेरिएशन करते हैं. SF4 Z कैलकुलेट करो जरा. S की कितनी है, 6. we have 6 ना for sulfur and no charge plus 4. 10 sir, 10 by 2 5 तो sp3d is coming, sp3d, that is TBP. now geometry is not equal to shape because one lone pair is there. How to calculate the lone pair? Z is coming 5 but shared is only 4. So 5 minus 4, 1. 1 is the lone pair we got. Now see how is the structure coming now. I will show you. You can see the structure is coming seesaw shape is coming. Got it. Seesaw shape, it's coming like a seesaw. So shape is seesaw but geometry is TBP, trigonal bipyramidal. Now let's take another example. XEF4, calculate the Z. half plus valence में 8, no charge, plus 4 monovalent, 12 by 2, 6. Z 6sp3 d2 octahedral will be the geometry that I can directly conclude it. But if geometry is not equal to shape, because 6 I want but only 4 are being said, 6 minus 4, 2 lone pairs I can say. So let's draw the structure. XE F I am drawing here. This you can see square planar. This is in a plane of square. It is in a plane. F particles are in plane. Square planar shape, but geometry is octahedral. Another example. This is for you to solve. CH4 H2O NH3. Tell me the shapes of these three molecules. First let's calculate Z. Half, 4 plus 4, 8. Z is equals to 4. So no lone pair are 0. 4 minus 4, 0. So this is as it is. Shape is equal to geometry. But in case of water, Z is equals to half. O is in the center. 6 plus 2, 8, 4. Z is 4. But here only 2 are sharing. 2 are lone pair. O, H, H. 2 lone pairs. The angle is reduced because of repulsion. NH3, Z is equals to half. 5 plus 3, 8. Z is equals to 4. Same. Hybridization and geometry are same. Just the shapes are varying. NH3. So this is bent shape. This is 3-1. I have given you already 3-1. Yes, what is this? trigonal, pyramidal, yes, pyramidal shape. This is normal or tetrahedral I am getting. So this was all about Vsepr theory. The theory which gives the shape of the molecule. The shape of the molecule, the theory is given. And remember that geometry is equals to bond pair, bond pair plus lone pair. But shape is equals to bond pair only. Shape is equals to bond pair only. And I will revise the Z. If Z is equals to 2, geometry is linear, hybridization is SP. If shape is equals to 3, geometry is SP2, and shape and geometry is trigonal planar. If Z is equals to 4, hybridization is SP3, and geometry is equals to trigonal pyramidal. Tetrahedral. And if Z is equals to 5, then it will be trigonal bipyramidal geometry and SP3D. If it is 6, octahedral geometry and SP3D2. If it is 7, then pentagonal bipyramidal geometry and SP3D3. So this is all for today. In the next video I will discuss with you hybridization, because these two topics are linked. Hybridization is very easy if you are getting this concept right, and after hybridization then we will discuss some more interesting concepts. Thank you.